Large-scale exploration, such as environment monitoring and search and rescue, is challenging for a single agent. Current multi-agent exploration algorithms need environment-specific parameter tuning. Their computational complexity limits the number of agents, and mapping and communication delays cause redundant exploratory sweeps. We propose a bio-mimetic heuristic approach that models frontiers as a virtual sheep swarm and robots as shepherds. A team of robots, each equipped with a range-limited perception sensor, is tasked to explore an unknown environment. Each robot runs an onboard mapping algorithm that generates a map as the agent traverses through the environment. The explored areas are depicted in white and the unknown in black, and the boundary between them are the frontiers. Each frontier from the frontier processor is initialized as a sheep of unit mass in the swarm processor. Each virtual sheep mimics the sheep swarm heuristics. Here we compare the differences between the heuristic model on the right and the proposed heuristic frontier model on the left. The inter-agent repulsive force, depicted on the right, ensures that no two sheep are close to each other. To create similar distancing as seen on the left, we merge virtual sheep within the vicinity. In the absence of a map update, the swarm estimator module predicts the next position of the virtual sheep by incorporating erroneous, predatory, and clustering forces. The erroneous and predatory forces are similar to the heuristic sheep. However, an opposing clustering force is used to mimic the frontiers properly. This allows the dispersal of the virtual sheep from the center of mass, depicted in yellow, while on the right we can see the heuristic sheep is attracted toward the center of mass in the presence of a predator. The swarm batching module uses the cumulative estimate of all the forces to segment and cluster the virtual sheep. This helps the agent to focus on a subswarm of the virtual sheep. Each agent selects one subswarm to chase after. Here the UAV chases the red cluster. The predator processor determines the next pose of the robot with one of two modes of operation. In the herding mode, the compact swarm is pushed by chasing the center of mass of the swarm. In the collecting mode, the swarm is not compact, and the UAV chases the virtual sheep furthest away from the swarm. To visualize the effect of the swarm estimator and mimic the delays from the frontier processor, here the map is updated once every 2 motions. The virtual sheep is reset with every new map update, and in the absence of an update, the swarm estimator outputs the position of the swarm. An in-depth simulation analysis was conducted in cluttered and uncluttered environments with varying agents and environment areas. Here we compare a 3 UAV team exploring a 3,600 meter squared forest area using FroShe, Greedy, and FAME algorithms. As evident from the simulation snippet with 3 agents, FroShe outperformed its peers. Experiments were carried out on a real-world forest using 2 X500 UAVs equipped with an OS1 LiDAR for mapping. Here, the drones are using FroShe to explore a 600 meter squared forest area. The 3D map, generated with octomapping by each agent, is shown in the middle, while the top-down view of occupancy maps with the merged point clouds is shown on the right. A bio-mimetic multi-agent exploration framework, FroShe, is proposed that is robust across varying environments and areas. FroShe is minimally complex, can be easily scaled, and ensures fast deployment. Thank you.